Hey, welcome back, you guys. I'm gonna confess, this is actually version 3 of this video. I just made about a minute and a half of version 2 of this video to realize that I was recording the wrong screen. I looked over and it said 3x3 matrices in the top. I went, that doesn't seem right. And I'm gonna have to ask for your humble forgiveness. But version 1 was the worst video I've ever made. I can't bear to have it see light of day. And unfortunately, I even went so far as to upload it onto YouTube and embed it into your notes. It was there, it was locked and loaded, it was ready to go. And then I realized that everything I told you in that video was a lie. So, don't call me the President of the United States, but I'm not gonna let that happen. So version 1 got scrapped. I erased it. I took it down. We're redoing it. Version 2 was an honest effort, but tech issues. And version 3 is going to be great. That's probably what you're seeing now. Unless, of course, you're not seeing this and there's a version 4 that I talk about. And it's been rough. 2020 is just not my year. It's probably not anyone's year. So we're all human. We make mistakes. So, we'll live with it. We'll work through it. We'll grow and learn. And we'll start by learning about 2x2 matrices with variables. So let's go look at that before we make 2020 any worse. So here is the problem with version 1 right here. Here you go, Barton, I've already learned the determinant of 2x2s. Yeah, I thought so too, kid. Unfortunately, I gave you the wrong formula. When we initially went over the 2x2 determinant, it was in the context of inverses. And the formula for the inverse of a matrix is as follows. It's the inverse of a matrix, if it exists, is 1 over the determinant of A times the matrix. Let me see if I can get this right. D minus B minus C A. And that's how we find inverses. In the first video, I believe that I have accidentally told you that the determinant of A, which can be written as such, is 1 over AD minus BC. That's not true. I didn't intentionally lie to you. Sometimes your parents tell you something that they wholeheartedly believe is true, and they just, didn't fact check their sources. So, yeah, I goofed. This is 1 over the determinant. It's this thing. This is the actual formula for the determinant right here. It's just AD minus BC. So the good news is your 3 greatest fears: fractions, open water with mysterious floaty things that you can't quite make out, but that dart away from you when you get a little too close, and fractions again. It's not a fraction anymore. No fractions. So we're going to go back and we're going to do the actual determinant of 2x2s, which is just AD minus BC. There's no fraction. There's no 1 over. That was a mistake because you do 1 over AD minus BC for the inverse. This is not the determinant, though. This is the determinant. So my bad. Now that we've really cleared the air and I think we can all be honest with each other here, let's just go do it correctly this time. So we want to know what the determinant of this matrix is, A. So the determinant, God bless America, each and every one of us, the determinant of A is equal to AD minus BC. So here's A. Let's see, be consistent. This is baby A. A, B, C, D. So we just fill these numbers into this formula and simplify. So A is 2, D is negative 2, minus, and that's from the formula here. This sign will always be a minus, and we'll clean up a double negative if we need to later, times BC. So B is 3, and c is 1. Then we just simplify this. So this is -4 minus 3, so that's -7. There we go. No more fraction. Much friendlier looking. We can all sleep at night. And you know, I feel like I've redeemed myself a little bit here. I don't want to say I've brought honor to the Barton family name, but I haven't dashed it upon the rocks of Tsushima yet. So you know, we'll there you go. There's a real determinant. All right, let's look at something a little bit scarier, just to hopefully prove to you I actually know what I'm talking about. For the determinant of this is where your homework is a little bit different from what you already know. Now they're going to go ahead and throw some variables in here. That doesn't matter. We still have A, B, C, and D. The determinant of A is still AD minus BC. So we're going to just fill those in and simplify like normal, if possible. So we're going to have x times -4 minus 3y times -1. Now we're going to simplify this. So x times -4 is -4x. And then -1 times 3y is -3y, but we have a negative here already. So it's -3y. And we can turn this into a big plus sign. So plus 3y. And then there's our determinant. We can't simplify that because these are not like terms. They're different variables, so they just stay separate. And standard form says we just put them in alphabetical order. So there we go. Hopefully, actually let's do this one. Just to really drive home that I am a math teacher and I know what I'm talking about for realsies this time. So one more, just for the kids in the back who were petting their chihuahua while they should have been watching the example. The determinant of A is AD minus BC. So this is going to be x times -6 minus 3x times -2. So this is -6x minus 3x times -2 is -6x. But this minus is out in front, so we can turn this into a plus. So plus another 6x. Now these are like terms because they have the same variable, so we just combine like terms with their coefficients. -6 plus 6 is 0. There you go. There is your determinant notes. Hopefully I've earned a little bit of your respect back. I know I may have done irreparable damage and you're never going to trust anything I teach you ever again. But you know, I think this has been a valuable lesson for all of us. You know, take time on what you do. Make sure it's good. Make sure it's something you'll be proud of when 100-something people watch it. Yeah. If you have questions about determinants, what it's like to misinform an entire class of students, or how to cope with shaming yourself, let me know. I've got answers to all of it, and it's probably something to do with math YouTube videos. So, well, now there's an awkward silence, huh? Nah, just kidding. All right, I'll see you guys later.